Good morning, dear students. Today we will be revising chapter 6, that is Combustion and Flame, which is the syllabus of your P2 exam. So what is combustion? It is a chemical process in which a substance burns in air or oxygen with the release of heat and light energy is called combustion. What are the conditions necessary for this combustion? Yes, first thing, combustible substance. That means the substance which will burn to release this heat and light energy. Sometimes it may release sound also. Second condition is supporter of combustion. That is availability of supporter of combustion, that is oxygen or air containing oxygen. Third condition is ignition temperature, that is the minimum temperature at which a combustible substance will start burning. What are the types of combustion? There are 4 types of combustion: slow combustion, rapid combustion, spontaneous combustion and explosive combustion. In slow combustion, the process of combustion is very slow, like burning of cow dung cakes, etc. And in rapid combustion, the process is fast, like in case of LPG gas burners. Third type is spontaneous combustion, where without any apparent cause, the combustion process starts, like forest fire or burning of phosphorus. Why it occurs, we have already discussed that. And the fourth type is explosive combustion. The combustion process where along with heat and light energy, the sound is produced because it is taking place in a closed container. Right? How do we say that combustion is going on? By seeing the flame. So what is flame? It is the burning region of the gases. Now this burning region or this flame has different zones which has different colors, and they release different amount of heat also. Let us understand this in a better way with the help of a candle flame. When we light the candle, we observe that the innermost zone of the candle is dark in color or black in color because it contains unburned wax vapor and it is least hot. Whereas the middle zone is yellow or slightly orangish in color due to partial combustion of the carbon particles, and it is moderately hot. Why this zone is having partial combustion? The reason is sufficient oxygen is not available in this region. Whereas the outermost zone is non-luminous and it is considered as the hottest part of the flame because of complete combustion of the wax vapor, and this gives maximum amount of heat. This zone is used for different purposes. The outermost zone or the non-luminous zone of candle is used by goldsmith. Why it is used by goldsmith? We all know the reason for it. As it is the hottest zone, it has the ability to melt the gold or silver. What are fuels? Fuels are the substances which are easily available and burns in air at a moderate rate, producing large amount of heat energy. At the same time, they do not leave behind any undesirable residue. Okay, so fuels are the substances which are easily available to us, and they burn with a moderate rate, and they produce a large amount of heat. At the same time, they do not leave behind any undesirable residue. Okay. These fuels can be broadly classified into three groups depending upon their state. That is, solid fuels, liquid fuels, and gaseous fuels. We all know the examples of these fuels. Like solid fuels means wood, cow dung, cakes, or charcoal, etc. And if we talk about liquid fuels like petrol, kerosene, diesel, they all come under liquid fuels. And gaseous fuels means biogas or CNG or LPG, methane gas, etc. are considered as gaseous fuels. Out of these, few of them they are derived from the fossils. So they are also called as fossil fuels. These fuels, when they burn, they produce heat energy, and that heat energy is used by us. Now, how much heat energy is produced by each one of them, that one should know. How to know this? So for that, we burn a fixed amount of this fuel, and we measure the heat energy produced by it. This is known as calorific value of a fuel. Calorific value of a fuel is the amount of heat energy produced on complete burning 1 kg of a fuel in pure oxygen. Okay, it is the amount of heat energy produced on complete burning of 1 kg of a fuel in presence of pure oxygen. Why we have mentioned here pure oxygen? You all know that in presence of pure oxygen, the combustion process will be complete. So this is known as calorific value of a fuel. And the unit of this calorific value of a fuel is kilojoules per kilogram. It is measured in terms of kilojoules per kilogram. Based on the calorific value and other properties of the fuel, we come to know the general characteristics of fuel. Out of these general characteristics of fuel, we can say that the so and so fuel is the best fuel. So what is the criteria for this, or what are the characteristics we expect in best fuel? In best fuel, we want it to be very easily supplied to the consumer. Second thing, it should not leave behind any ash or solid residue on combustion, and it should produce very less amount of harmful gases. Another property which we want in best fuel is its ignition temperature should be low, and its calorific value should be best or highest. Now you have understood what is combustion, what are its types, and how they give heat energy, how to measure this heat energy, and which fuel gives maximum amount of heat energy, etc. Apart from all these characteristics, there are problems related to combustion of fuels. When we burn or when we use these fuels for different purposes, they produce lots of harmful gases such as carbon dioxide gas, carbon monoxide gas, sulfur dioxide gas, nitrogen dioxide gas, etc. So carbon dioxide gas, as you know, it leads to global warming, and carbon monoxide gas, it causes respiratory problem, whereas sulfur dioxide gas and nitrogen dioxide gas, is responsible for acid rain. Apart from this, the carbon particles are released in the form of smoke, and large amount of ash is also produced when we burn some fuels. So all these are the harmful effects of combustion of fuels. So we have to select the fuels wisely so that they will cause less harm to the environment, and at the same time they will give us heat energy or light energy for which we are using them. I hope you have understood this chapter very well. So all the best for your exam.